Okay, so we are finishing our notes on section 3.5. The Gaussian model is used in probability and statistics to represent populations that are normally distributed. That means normally distributed in quotes, all right, which means it's a bell-shaped curve, a normal distribution. All right, the model looks like this. Let's take a look at example 4 on page 261, because the average value for a population can be found from the bell-shaped curve by observing where the maximum y value occurs. The x value corresponding to the maximum y value represents the average value of the independent variable. So let's take a look at page 261, example 4, SAT scores.
Is there one of those similar one on the gift?
I believe so. In 2004, the SAT math scores for college-bound seniors roughly followed the normal distribution given by that model, where X is between 200 and 800. Okay, and X is the SAT score for mathematics. You're supposed to sketch the graph of this function, obviously using a graphing utility. From the graph, estimate the average SAT score. So once you type it in, you see that the bell-shaped curve was at a maximum at about 518, and you can find that out using, menu, analyze, maximum, right? What's wrong, Andrew? Okay. And nothing's coming up? Are you trying the one for example 4? Or are you trying about the one on the gift? Well, we're on example 4 on page 261 right now. Okay, questions on this? Okay, so let's take, now that we know what we're supposed to be looking for, let's take a, do I have one like that on your gift or no? Shoot, what's number 5? Oh, okay. All right, so last year the math scores for students in a particular math class roughly followed the normal distribution given by, let's see, did I have you folks log in? Why don't you, not enough time. All right, so I tell you what, let's go to, I do have, Harrison, are you still logged in? Yay. All right, Harrison, live presenter. All right, Harrison, you're going to go to a graphs page. And you are typing in 0.0399 times e raised to the, so use the e to the x button. We want, let's see, let's pull up a fraction template there. Controlled divided by. And we want opposite of, left parentheses, x minus 74. Everybody's doing this on your own calculator. Right parentheses, squared. So you got to get, there you go, squared. Now go down to the denominator, 114. All right, go ahead and graph this, push enter. Okay, we're seeing like a whole lot of nothing. Well, I tell you what, let's look at the clue. They say the x is between 30 and 110. So the scores were between 30 and 110. So window zoom, window settings. Yeah, let's do minimum 30, maximum 110. And let's make, I'm assuming that these scores go up to,
They don't move. Like they score to 0.
no, all right, so I tell you what, let's make the y minimum 0 and make the y maximum 1. We're starting to see a little bit. So go ahead and make it, instead of 1, make it like 0.1 for the y maximum. Okay, so at this point, go ahead and do menu, analyze, maximum, and left lower bound, upper bound, and turns out to be what? 74. So it says estimate the average math score. So what was the average math score? 74. All right. The y corresponds to
Why is it so small?
yeah, that's a really good question. Oh, that's the distribution. on that axis. Yeah, well, see Mrs. Kelman, the statistics department for that one.
Wait, what's the equation?
But that's the distribution of like how many students, like that's a measure of how far the data was spread. I'll talk to her about that and I'll get an answer for you next class. Okay, so meanwhile, let's get back, thank you, Harrison. Let's get back to our notes. Logistic growth model, we talked about this. Some populations initially have rapid growth, followed by a declining rate of growth. One model that describes this growth pattern is the logistic curve. Another name for this logistics curve is the sigmoidal curve. All right. They have a graph of this on page 262. If you take a look at page 262, nice example of a sigmoidal curve. All right, so let's take a look at number 6. Is this on your gift? Okay, on a college campus of 7,500 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by that logistics growth curve equation, where t is greater than or equal to 0, and y is the total number of students affected after 3 days. The college will cancel classes when 30% or more of the students are infected. So how many students will be infected after 4 days, and after how many days will the college cancel classes? So for this particular problem, to find out how many students will be infected after 4 days, we're going to do what? Plug in 4 for t. All right, so would you do that now, please, on your calculators? And Harrison, counting on you again here. Yes, calculator page for right now. And you're just doing 7,500. You know what, I tell you what. Just do this, Harrison, just do this on a graphs page.
Oh, on a graph.
Yeah, do it on a graph, add a graphs page. I would say, I mean, you guys do a lot of stuff in Scratchpad, but I would actually make a new, make a new page for this. Oh, we're not getting to the earthquakes probably today. Okay. All right, so 7,500 over 1 plus 7,499 times e to the negative 0.9x. All right, excellent. We're graphing that. Okay, and at this point, pull up a table, Control T, because we want to know what happens after 4 days. So after 4 days, there are how many students infected? 36. So how will we know after how many days will the college classes? Oh, you know what? I tell you what, Harrison, I would like to see this shape. So I want you to adjust your window so you can see. Oh, here, I'll write it up here. We want to see this shape happening, right? Right now, I'm only seeing like this much of it. I want to see it like leveling off. All right. So how far are we going to have to go up to? Windows, zoom, I would say number of students better go up to at least 7,500. Wait, not for the x, that's number of days. So number of days, let's go to, I don't know, 100 days. And let's go y minimum 0 students, y maximum 7,500 students. Yeah. Okay, all right, so we're seeing it kind of leveling off there. Would you agree? All right, we could actually, once you go up to like 8,500 or something, so we can, Control T, we'll get rid of the table and bring it back in. If it's not getting rid of, take your cursor and slide over to the graph part and click on the graph part and then try Control T. Okay, so we're seeing it leveling off there, right? Okay, you know what? I don't even think we need to go out that far to 100 days. We could really go out to maybe just 40 days or something like that. But my point is, after how many days will the college cancel classes? Well, we need to know when 30% or more of the students are infected. So how do we know that? So 0.3 times 7,500, that would be 30%. of 7,500, how many students is that? 2,250. So we want to know when is it going to be equal to 2,250. So go back to your graph, please. And can you add a new function? Push tab. And let's just type in 2250. Enter. All right, right there is the, whenever that meets, right, is going to be intersection, sure. Intersection, get to the lower bound. All right, can you slide that out of the way? 8.97. All right, looks good. So 8.97 what? Days. So it looks like right around 9 days after the student came back, the school will have to cancel classes because 30% will be infected. Are we okay with this? All right. Let's see. Going back to this. Now, the next thing is the logarithmic models. We did already talk about the Richter scale and earthquakes. Yes? A little bit? All right, so we have this model, R equals log of I over I sub 0. That's the letter I, where I represents the measure of wave energy, and I sub 0 is the minimum intensity used for comparison purposes. So, well, let's get to the one on your gift. So if we want to find the magnitude R of an earthquake of given intensity, we're going to use that model. R equals log of I over I sub 0. Okay, so we're going to be plugging in what? R equals log of I over I sub 0, right? Yeah, and they just use 1 for that. Yeah, I sub 0 is equal to 1. So we're going to use R for the Richter scale, log of 68,400,000 over 1. So what is the log of that? This is really asking 10 raised to what power gives me this? So what do you get? 7.83 would be the Richter scale rating for this. Does this make sense? No? Okay, so you're going to check my website for the homework assignment on 3.5. We'll go over homework on 3.5 and have that as our review day on Monday, and we'll test on Tuesday. All right? And I know I'll be seeing many of you today or tomorrow to finish up this probability project.
Bye, Ryan.